And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only A, and this is only 1. But you want to be careful though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. Gets splitted here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also, from the household, there could be some control messages being sent, for example, to switch channels. Okay, for example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household as well as in the central office of the cable company. Yeah, I know, if you look at this picture here, you see, very familiar, right? Just like DSL. If there's signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there's this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay. And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Now these messages coming from the household, They will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel to a different TV program, is only just one subband, right? And so they kind of run on frequency subbands that are not overlapping, completely separated, so that they will not be interfering with each other. Okay. So that technique is formally called frequency division multiplexing. Okay, so we kind of cut the entire frequency band into non-overlapping subbands, division over frequency, hence the name.